Okay, G, you've talked a lot about the sampling distribution of means. Can you have other sampling distributions that are not means?
Yeah. And will they look just like the sampling distribution of means? Because we see that the sampling distribution of means is pretty cool. It has some cool properties, right? Like for instance, when the n is pretty large, you get this roughly normal shape, right? That's kind of a cool thing. All right, so let's look at some other sampling distributions of other statistics, right? So here you could actually change the statistic from mean to something like median, like I've done here, but there's a lot of other options, so feel free to play around. So I'm going to use this normal distribution because this standard deviation has this nice whole number of 5, and I could easily square that to get the variance. And so the variance of that would be 25, right? So I'm going to write down the variance here. So I'll put sigma squared equals 25, just so that we're reminded, right? And I want to show you, well, can we have a sampling distribution of variances? Now in this case, you could actually use variance or variance U. Variance U means the unbiased variance. This is the one where you divide by n minus 1, right? So I'm going to use that because that's the one that's often used to try and estimate the population variance. And we're going to look at a sampling distribution of variances. So let's take 10,000 samples and calculate the variances this time of each of those. First thing off the bat, not normal. Even for a large sample size is pretty much not normal, right? So there goes that idea. But take a closer look. Take a look at the mean of this distribution of variances. It's 24.77. 25-ish, right? And so here too, this is 24.96, 25-ish. Let's think about what that means. That means that for any sample, we're going to take these random samples, right? For any sample that we draw from this population, if we calculate the variance from it, those variances are largely clustered around the true variance of the population. Ha ha ha, even for a small sample, right? Now, it turns out that if you have a larger sample, those variances are more tightly clustered around the true variance of the population. And that's why I want to bring up this idea. We've been calling some of these statistics estimates, right? And you don't often hear that in other statistics classes, but here's the reason why. We are often using the sample to estimate something about the population. You could see why the unbiased variance is a good estimate of the population, because it really does cluster around the true variance of the population. So it's going to be off, and here's how off it could be. It could be off way over here, it could be off way down here, right? But on average, it's going to cluster around the true variance of the population. That's what makes these good estimates.